Friends, we now move on to the next lecture, which is the fourth lecture titled Probability and Plausible Reasoning under the online course titled Risk and Reliability of Offshore Structures in Module 1 organized by NPTEL IIT Madras. In this lecture, we will discuss about some important rules of probability and introduce you to what we call as plausible reasoning. We already said in the last lecture that reliability is governed by uncertainty, and reliability is one of the effective tools to handle uncertainty, and therefore, reliability is always advantageous to be expressed in probabilistic terms. Now, the question comes, if the uncertainty is not properly handled in the analysis stage, how does it propagate? What would be the influence of unattended uncertainties in forms of data in the final result? On the other hand, how uncertainty propagates? Uncertainties are primarily responsible for making the reliability studies probabilistic in nature. However, it is very interesting and hypothetical of course to inform that if every event present in the analysis, design, construction, planning, layout of offshore structures are completely certain with high degree of confidence and occurrence of the event, and there are no uncertainties involved with these events, then one can say that reliability study can be always become deterministic. You need not have to actually look at the probabilistic tools at all. When you are having a guess or a chance of not covering certain events or influence of certain events on the other, what we call cross correlation factors, if you have a fear that such factors might have been overlooked upon in your analysis, then reliability studies should be governed under the basis of probability theory. So, probability tag that is associated with reliability makes it more mathematical. Otherwise, reliability is generally visualized as a study based on engineering judgment. Reliability is nothing but a physical or engineering judgment based on past experience. This appears to be an abstract statement. Therefore, reliability is comfortably converted into a mathematical modeling using probabilistic tools. Uncertainty propagates in many ways. It can be probabilistic, it can be non-probabilistic. If you look at probabilistic approaches, how uncertainty propagates, it can happen by two ways. You can look this problem by two ways. One is you can look using probabilistic approach. You can also solve this using non-probabilistic approach. You look at probabilistic approach, there are various methods which can be generally adopted for understanding the propagation of uncertainty. Under this, the first class of methods which come in probabilistic approach is simulation based methods. We can name a few of them: Monte Carlo simulation, importance sampling, adaptive sampling. Can also have local expansion based methods. Under this we have got Taylor series, one can also include perturbation methods. As non-expansion based methods. These methods are good to deal with small variability of input and output without high nonlinearity. If the input and output variables have high nonlinearity in nature, obviously these methods, both simulation based and local expansion methods, are not very effective to handle them. There are alternate methods which can also be used, which are also probabilistic approach to handle or to model the propagation of uncertainty. Under this, the first class of methods will be functional expansion based methods. We can cite a few examples on this: Newman expansion, orthogonal, or Carthunan-Liouville expansion, which is abbreviated as K-Lee approach. One can also have polynomial chaos expansion, which is abbreviated as PCE in the literature. Of course, one can have wavelet expansions also. So, all these will be included in the subset of functional expansion based methods, which are alternative methods compared to these two, and of course, they are also included under the braces of probabilistic approach to model the propagation of uncertainty in the variables. You can also have the next set of methods, which is most probable point based methods. Under this, we have first order reliability method, which we can abbreviate as FORM, second order reliability method, which is SORM. The third set of methods as alternate methods to the classical methods, as you see here based on simulation, will be numerical integration based methods. We can also name a few of them under this heading, which is full factorial numerical integration, F, FFNI. The method related to dimension reduction, DR method, is also useful, which is one of the numerical integration based methods which can be used for modeling the propagation of uncertainty. Alternatively, you have non-probabilistic based methods like interval analysis, fuzzy theory, possibility theory, evidence theory. Probabilistic approach is of course a rigorous approach to do uncertainty analysis. It is because of a simple reason, because it is consistent with the theory of decision analysis. For example, in regression analysis and least square problems, standard error of the parameter is readily available. So, this can be further expanded into the confidence interval to verify or ascertain the solution obtained from the analysis. Having said this, let us try to list down what are the major challenges in reliability analysis as a whole. Essentially, there are two major challenges which are focused in the literature. One is arising from model inadequacy. Which of course leads to parameter uncertainty. Second could be the lack of data which is required to do the analysis, which can arise both from numerical simulations and experimental investigations. Now, to solve these issues which are dominating the challenges in reliability analysis, people use modular Bayesian approach. Modular Bayesian approach can be used to address such complexities. This approach used to inverse uncertainty quantification, and it is a better way to express the uncertainties in terms of circumscribing, which is shown here, which are posed as major challenges in reliability analysis. Now, the modular Bayesian approach has actually, as the name suggests, it has got 4 modules. We will quickly see each module one by one and talk about what is the use or role of each module in the whole analysis. So, modular Bayesian approach does the analysis in 4 module procedure. In the first module, it deals with Gaussian process modeling. I will use GP for Gaussian process modeling. for the numeric model. The second module deals with Gaussian process modeling for the discrepancy function. The third module deals with the posterior distribution of unknown parameters and the fourth module, which is the last module, deals with the prediction of experimental response and the discrepancy function. Let us quickly elaborate each module and see very briefly how are they contributing to the whole analysis. If we talk about module 1 in modular Bayesian approach, the main problem addressed in this module is issues related to lack of simulation results. In this module, numerical model is replaced with the Gaussian process model. So, the numeric model is replaced with the Gaussian process model. The replaced Gaussian process model, which is used instead of numeric model, is given by the following equation: y of m x theta is approximately equal to the Gaussian process of h m of the function transpose beta m and sigma m square r m of the parameters. I will call this equation number 1, where R m of the parameters x theta and x dash phi or theta dash is actually given by exponential of minus summation of k equals 1 to d, and the summation is applied through the function k m x k minus x dash k square multiplied by exponential of summation of k equals 1 to r, which now goes with w d plus 1 m, not d plus 1, d plus k m of theta k minus theta k dash square, called equation number 2, where d is the limit of summation indicating the dimension of the input variable, r is that of the unknown parameters. Hm is predefined for a given problem. Beta m, sigma m, w k m for k equals 1 to d plus 1, are known as hyperparameters. These hyperparameters of the Gaussian process model. These hyperparameters can be estimated, these hyperparameters can be estimated through the maximum likelihood estimates. This is a very recommended generalized technique which can be used as one of the powerful module in the modular Bayesian approach. In module 2 of the modular Bayesian approach, this deals with the Gaussian process modeling. The main problem addressed in this module is the issues of discrepancy function. In this module, discrepancy function is replaced with the Gaussian process model, whereas in the earlier case the Gaussian process model replaced the numeric model. So, the discrepancy function is replaced using Gaussian process model. Now, the Gaussian process model which replaces the discrepancy function is given by the discrepancy function is called as del x, which is approximated to the Gaussian process model of h delta of the function, beta delta, sigma delta square, r delta of this. Let me call this as equation 3. The r delta is given by the exponential of summation of k equals 1 to d w k delta of x k minus x dash k square, which is equation number 4, where the meaning applied as same as in the earlier case. The prior distribution of unknown parameters based on the data obtained from numeric and experimental studies, one can derive the maximum likelihood function. So, we can say based on the prior distribution of unknown parameters, one can derive the maximum likelihood estimates of beta delta, sigma delta, w k delta, where k is varying from 1 to delta. In case of module 3 of the modular Bayesian approach, Bayes' theorem is applied to calculate the posterior distribution of unknown parameters. The Bayes' theorem as applied to the posterior distribution of unknown parameter is given by probability of theta with the data available on phi is proportional to probability of data given theta and phi with probability of theta. It is called equation number 5, where in the above equation phi includes the prediction of experimental, includes the hyperparameters, of both the previous modules. That is module 1. In module 4, it deals with prediction of experimental response and discrepancy function. Together, all the 4 modules of modular Bayesian approach is considered to be one of the effective tool to address or to model the propagation of uncertainty. Alternatively, one can also look at the literature for a full Bayesian approach. The earlier what we saw was a modular Bayesian approach. Alternatively, full Bayesian approach can also be used to model the propagation of nonlinearity. According to this method requires a prior estimation of unknown parameters. This method requires prior estimation of unknown parameters, in our case let us say theta, and hyperparameters in our case phi. So, following steps are important in case of full Bayesian approach. Derive the posterior distribution first. Which is probability of theta given phi theta phi given data, followed by which integrate the hyperparameter to obtain the probability phi given data, proceed to predict the experimental response and the discrepancy function. This method of course has a major drawback. For most of the cases, the probability p theta phi data is highly interactable function. Of phi, making the integration a complex procedure. So, it is rather very difficult to obtain or to follow a fully Bayesian approach. Therefore, literature suggested modular Bayesian approach, which we discussed few minutes back. So, ladies and gentlemen, in this lecture we try to introduce you to probabilistic tools. We mainly focused on probabilistic and non-probabilistic approaches to model the propagation of uncertainty. Of course, we have established a fact in the previous lectures that uncertainties govern the reliability tools, and reliability is a positive phase of looking at the failure of the system, whereas risk is more or less a prescriptive tool which results in recommendations of rules and governance. We close the lecture at this moment. We will continue with the discussions on probabilistic tools and plausible reasoning in the next lecture. If you have any doubts for any clarification, please do write to NPTEL portal site and also parallelly read all the references listed in the website of the course. Thank you.